Oh, hello there. Hey guys, what's going on? Memes here. And yes, today, as the title may suggest, Professor Witten would not lead us astray. I mean, at least intentionally or and everything. It's like, listen, like he is literally the only physicist who has won a Fields Medal. So, um, I'm just noticing the broadcast kicking in there. Um, all I know is it's a crazy world out there. What we're gonna do is we're gonna take a look at some of Professor Witten's things. Because some folks will say some things that some may consider conspiratorial or something like that, like Professor Witten is just so smart and he's holding up string theory to lead us astray. Now again, I ain't no god nor prophet. Maybe somewhere in the multiverse, maybe that is the case. But ultimately, is the thing. Professor Witten is the only physicist to have won a Fields Medal. Basically, that's the quote unquote Nobel Prize in mathematics. No other physicist, to my knowledge, has done that. But then again, it is a kind of crazy and wacky world out there. But what we're going to do is I've been listening the IHS, the Institute for Advanced Study, basically home to some of the smartest folks in the world. Professor Witten, to my knowledge, is a resident and one of the coordinators over there, to my knowledge. I might just be making up that last part, but I know he works over there, and they just had a conference. And basically, there's a talk I've been listening to. It's titled "An Observer in the Center Space" and Rereading Everett by Professor Ed Witten. Here's the thing: you might not agree with string theory. A lot of folks, and again, it's like the majority of physicists are not string theorists and everything. That's the thing. But even if you don't believe in it, it's like, oh, those all these extra dimensions. You can't say it's not mathematically rigorous. That's the thing. I'll come across different string or membrane based papers, and I'm like, okay, well, here's an interesting thing that at least is interesting to me. And again, I have my own biases because there was like a 5-dimensional brain theory or something. It's like, oh look, that's the volume of the Giesking manifold or a hyperbolic tetrahedra or something like that. So it's like that's cool. And again, it's if you do the first time you do like the string tension equation. Hold on, let me find it. String tension equation. We got tension on a string in newtons or kilograms meters per second. Mu is the density or mass per unit of vibrational length. Vibrating on a string scale. Blah blah blah. Based on wave speed, the wave velocity on the string, and then the mass. Blah blah blah. It's all I know is the first time I did. I'm like, oh wait. This would have a propagation speed of the speed of light if you throw it in with Planck units. I'm like. Oh, well, that seems to make a lot of sense here. We'll just show the standard thingy right here. All right, let's go over here. All right. Okay, and again, there's the overview. Okay, so we got our tension here. Blah blah blah. Vibrating length. Okay, so the frequency, aka the cycles per second, the number of notes, and everything. Okay, so the tension, oh, look, mass times whatever the gravity, at least for just a normal hanging string there. I'm like, oh, look, 9.8 like meters per second squared. Oh, that's just standard gravitational acceleration. The concept makes a lot of sense. And then if it is mathematically rigorous, that's cool. And now again, maybe we need a collider the size of the solar system in order to test for it because what is it? Minimal string in M theory is 2 pi Planck length. It's going to be, oh, look, the length of a putative string in M theory. It's because it's a minimum length times. Well, if you're going to have a string, you got to kind of have a wave. And basically, your sine wave is basically just 2 pi. And if you wrap it together, you can have your little oscillations, bada boom, bada bing. We could test string theory We just need a ginormous collider that we can't yet build. But in theory, we could. Okay. But then again, it's like, all right, maybe these extra dimensions are of the magnitude we could actually probe. I've heard, again, we were talking about this a little bit the other day. I think it was Professor Kumran Vafa was saying testing string theory. Kumran Vafa testing teasing. I don't know, I didn't even spell it right. Testing string theory. Basically goes into, to my knowledge, I think they were looking at maybe the Newtonian gravitational constant goes from that 1 over r squared. Basically, you get your mass 1 times your mass 2, divide by whatever the distance between the centers is squared, and use the constant of proportionality, the Newtonian gravitational constant, and then you're going to get the effective force between the two gravitational masses there. Okay. Long story short is maybe it's around 10 to the minus 8 meters. 10 to the minus 8, you're like, well, that seems pretty small, but a meter's about, yay. We're on about a meterish scale. It's like, all right, go down 100 million times smaller. 100 million, well, 10 to the 8, 10 to the 6 means there's going to be 6 zeros in front. So that's a million, because a million has 6 zeros in front of it. 7 would be 10 million. 8 zeros, aka 10 to the minus 8, that would be 100 million times smaller than the magnitude on which we exist. That's ridiculously small, but it appears to be within our realm that we may actually be able to test. Hopefully sooner rather than later. And who knows, maybe all of a sudden, gravity all of a sudden just goes up to r cubed at this magnitude. We found the extra dimensions. Now, if we probe and the gravitational constant holds at that 1 over r squared, which again, it's according to our knowledge, it seems to be that way. And again, it does seem kind of elegant because at the Planck scale, these things do kind of unite because, well, if you just take your mass 1, and let's just do Planck mass times the Planck mass. Okay, those are our two masses. They are equivalent. Let's divide it by the minimum of length, the Planck length squared. I mean, we could just write Planck mass squared because it is the same mass, but throw our extra protective brackets on here. We do our little calculation again. There's no constant of proportionality here. We're just doing Planck mass squared over the Planck length squared. Okay. So I had no correspondence. Why? It's just mass divided by a length. You take the square root of that, but we apply big G, the gravitational constant of proportionality. We would like it as a unit. Thank you. There we go. Oh, and look, we get a ginormous amount of force in newtons, aka the Planck force. Fantastic. Okay. So what happens if we change this? We'll keep the length scale the same. Let's change it from mass to charge. Electric charge. Now, the constant of proportionality for that is Coulomb's constant. Because when you look at the equations, it's basically the same thing, except you're comparing charges and an inverse square law to another constant. And this, oh look, the same ginormous amount of newtons, that gives us the Planck force. So at the limit to our knowledge of the boundaries of physics as we know it, the Planck mass and Planck charge, aka the Newtonian gravitational constant and Coulomb's constant, at the limits of reality as we know it, equate out to the same maximum force. I mean, that seems quite beautiful to me. But again, the Planck mass is it's about the mass of a grain of dust. It seems to be a limit of which, if you were to shove that mass or mass energy equivalent into a Planck volume, aka a Planck length cubed, you shove into that volume, you're basically going to get a black hole. Some may say that is the universe acting in a method of protecting, like, error correction. I've asked different folks, and it seems to be almost error prevention. Because if that would exceed the limits of our reality, it's almost like you might break reality. Now, full disclosure, as somebody that runs a satirical show called Breaking the Multiverse, one would consider that I would be open to that. But then again, if I live in the universe and we were to break it, that seems like it's a bad day for you, me, and the rest of reality as we know it. So maybe we should avoid that. But let me jump into the chat and see what folks are thinking here. Welcome, Poindex. That's the thing. It's, again, the first time I heard about him, like probably many folks on the greater YouTube sphere, is you hear him referenced by Dr. Eric Weinstein. And the way he portrays him, it's like, he is terrifying. He's the one person that, like, terrifies me. And if you were like me and you were kind of maybe on the more of the kind of the political side of things, when you got introduced to Dr. Eric Weinstein, you're like, oh my God, Ed Witten is the final boss of physics. You're like, I thought the final boss of physics was trying to figure out what was actually going on. It wasn't supposed to be, oh my God, be terrified of this person. This person scares me. But then again, you'll hear different folks. I think it was Professor Maldacena or somebody at one point where they had an office next to Ed Witten, and they're trying to come up with a physics paper. And this back in the day as the typewriters. And all that, maybe it was Brian Greene. I think it was Brian Greene. He was at the IAS for a little while. And then it just, on the room next to him, he's trying to come up with an idea, and he just hears just a typewriter just typing away, and you're like, it was terrifying, the amount that guy could put out and calculate and everything. And when you listen to him, he has a very particular tone, cadence, and he is terrifyingly accurate with that. So when you're going to entertain the idea, it's like, oh, there's one dude attempting, just because he's smart and so quick on his feet, attempting to lead physics astray and hold us back. That's a very strong claim. That would require an incredible amount of strong evidence to try to prove that. Now, if you just want that to be true, of course it's true. It's just like whenever somebody you don't like, there's a negative headline. Oh, of course, I knew they were going to do that because they're a terrible, horrible, no good, very bad person, yada, yada. Basically, when you start needing to use the adjectives from a children's book like Alexander and the terrible, horrible, no good, very bad day, I consider there may be a little bit of bias involved. Now, again, that goes the other direction. If something bad happens to somebody you like, the story instantly becomes, oh, well, there were extenuating circumstance. Oh, they made a mistake. We should be forgiving. Or no, it totally wasn't them. No, it's blame the other people. They're terribly, horribly, no good, very bad people. I'm sure nobody has noticed any headlines like that for anything. M theory is, well, here's the thing. And again, I'm biased on this, but it's like, all right, to my knowledge, you had five primary types of string theory there. And it had to write this, B, type 2, blah, blah, blah. But they all seem to have some equivalence. Now, my thought is, how are those attempting to probe into reality? Because if there are 5 dimensions of measure, aka you need at least 5 constants to create the units along with mathematics of our world as we know it, which is basically h bar, the elementary unit action, the speed of light, as well as big G, the Newtonian gravitational constant. And then you need an aspect of electromagnetism and temperature. And those you can get from the electric constant and Boltzmann's constant, which coincidentally allow you to form 5-dimensional Planck units: the Planck time, the Planck length, the Planck charge, the Planck mass, and the Planck temperature. I remember when Thad originally had told me that. I'm like, oh, that's kind of cool. I just kind of took it with a grain of salt. And then you start going through, you calculate, and you're like, oh, yeah, these are the 5 dimensions of measure, as far as we've categorized things, that we seem to need to replicate reality as we know it. And again, sometimes we got to measure things. Those will give you the dimensional aspects to get to why the electron has the mass it does. Those are things, as far as we know, come from measurement. There's no clear, agreed upon reason. Now, again, I'm biased because, like Dad and some of the folks in the monastery would say, well, we have a closed form answer, or at least candidate, for the electron mass. Seems to match pretty well. And we're trying to use, this is where I think, where is it? Dirac or something. Somebody said, quote unquote, beauty is more important than agreement with experiment. Now, my thing is with this, I feel like you can kludge. You can just put together whatever series of things you want to get whatever number you want. I've totally done it. Oh, I can match the anomalous magnetic moment of the electron to 14 significant digits. No problem. I can come up with a closed form that will match the data. Now, does it mean anything? Because I could just form it in a whole bunch of different ways. The thought would be, well, if you can do that, you should be able to find a pattern between the anomalous moment of the electron, the anomalous moment of the muon, and the anomalous moment of the tau. Basically, the 2 other generations of leptons as we know it. Now, to find a consistent pattern that you can intuit between all of those, that is more difficult, my friends. I wasn't able to do it. I tried. Eventually, I'm like, okay, I didn't find it. And then Thad went through, and he's got some things now. But again, we're open to other ideas, and maybe some of this AI pattern matching and stuff, or maybe some of these viewers like you may be able to help us crack the case. All right. Threads. Hey, Bill, what's going on, my dude? Good to see you, my friend. Good to see you. Now, we're just talking about a lot of folks like to, well, case in point, I'm a person on the internet. Why did I start a YouTube channel? Because I got tired of yelling at the television. So I came on the internet to complain about things. I'm sure nobody else would ever do that. But it's very easy to complain and turn people out into be villains and stuff like that you've never met. Now, I'm sure nobody has ever done that, because that would be wrong and taking advantage of human nature. But I digress. Welcome, Maximus. Good to see you, dude. To be fair, there is a maximum acceleration. It's the Planck acceleration. Just I only know this by asking questions and eventually looking at things and be like, what is that? Planck acceleration. It's basically, I'll give us the definition here. So as we can see here, the definition. Basically, all these Planck units you can take by combining different constants in nature in different forms. So basically, this is the speed of light to the 7th power divided by big G and H bar, and you take the square root of that. We get the Planck acceleration. What is that? 5.561 times 10 to the 51 meters per second squared. That's quite the acceleration, my friend. The interesting thing here is also, if you are accelerating, as long as you are accelerating, you technically, it's theorized that, and I believe I've heard there's experimental evidence. I haven't really looked at it myself, so take it with a grain of salt. I see an under temperature here, but it's very similar under acceleration, because also the quote unquote Hawking entropy for a black hole, it's basically the same equation for the UNRRA thing, because it's believed that the effective gravitational force, because it's technically, to our knowledge, not a force, this is the quote unquote bending or curvature of space time itself. Okay, whatever that actually means. Now, if you notice, this is not the Planck temperature. This is kind of close. Oh, it doesn't have the Planck. It doesn't have it over here. Right? Nope. We need 2 pi, I believe. It's either 2 pi or 4 pi. There we go. So basically 2 pi. So basically a cycle of that, it would get you up to the Planck temperature. Why? Because to get the Planck energy, basically if you do 1 over the Planck time, you'll get like 12.2829 or something giga-electron volt. The Planck energy is actually like 2 giga-electron. Basically, long story short, is if you do 1 over Planck time, and a lot of this stuff is just filling in from just doing that. Okay, Planck frequency, blah, blah, blah. Okay, so if you just do the standard h bar times that frequency, you're going to get this, which is like, 12.29 gigajoules. Yeah, which is basically 2 pi Planck energy. Okay, this is not actually 137 micrograms. This got my noggin a jogging before. It's like 136.5-ish or something. I totally went down that road. I'm like, oh my God, it's a clue. It's a clue. No. To be fair, 7 molecules of water divided by the full tessellation, or the entire sum of the periodic table, just taking the single most common elements that we have on there, it is closer to the fine structure constant than this. Again, I dove right in. I'm like, oh my God, give me that alpha, baby. It didn't work. So that's why if something looks like something, maybe it is, but you also need that precision. So that's why if you're going to say something is equal to something and it deviates after 2 or 3 digits, it's like, maybe all the experiments are wrong, but if we have it measured to like 10 or 12 significant digits, it's like, I don't know, what's easier? All the experiments are wrong, or you're incorrect. This is where now you can say it's of magnitude or approximately. Just we got to be careful with our words here. But so you need to divide this by 2 pi. So yeah, and that gives us the Planck energy. So basically, at least within time, there's a cycle, and I know Fractal Woman has been another YouTube channel that I think is pretty interesting. She's worked in, pardon. Now that I've scorched my vocal cords from coffee that's a little still too hot. Yeah, so there's a cycle involved, and that's one of the things that Fractal Woman was looking at like a lot of these 2 pi factors, would be like, well, maybe we should view this in the terms of cycles. So she was on, I think, Unductica. It hosted her, and they have about an hour and a half or so chat about her method of unit analysis. And again, I think conceptually, I like the idea. You have to be careful, because as soon as you're going to say every single 2 pi, when she got to alpha, she kind of included that and kind of didn't because of the denominator and the Planck, but you have to go watch it. And again, it would be a Fractal Woman. Because when you look at these units and everything, it's a lot of stuff makes sense. But then other things, you're like, oh, why is this the case? And a lot of these things do have answers already. You just need to ask the right question, because a lot of times it's like, oh my God, I discovered something fundamental. And then it's like looking, find literature, and it's like, okay, well, that's already been noticed and stuff. You might not hear about it in like a Wikipedia article, but at least if you're using at least the more modern, like at least pay for ChatGPT, it does a pretty good job of finding you actual sources and stuff like that. I didn't even know, because what was it? When Demystify Psi had their infamous most recent meeting in Professor Keating's office. Oh God, this sounds like the beginning to like a bad like horror film or something. began in Professor Keating's office. And they're going off, and it's like, no, but Brian, no, we have never on Earth created a quote unquote black body type radiation from a gas. I just put it in the chat GPT. I'm like, hey, listen, I got some friends that are saying this. I got my other friend, a professor, he's saying this. Here's the argument. What's going on here? And it literally found a paper from like the past 10 years that's like, it appears that we've observed black body radiation. And Anastasia's like, oh, this is some pretty extreme circumstances. I'm like, yeah, it's under some really extreme circumstances, which, I mean, to be fair, if you're going to say the beginning of reality came from a hot, dense state, potentially at some point being at the blank temperature, that seems like a pretty extreme state. Now, again, to at least the AI agent's actual thoughts, or at least how it was evaluated, I'm like, is this an actual black body? It's like, it appears to be a black body. But again, there is a cutoff, like Anastasia pointed out. I'm like, okay, there was a cutoff here. And he even says, yeah, no, it could be a gray body radiation. But again, it's a very difficult thing to do. And you can say, oh, 10 to the minus 20, 10 to the 23 pascals or something like that for pressure, under pressure. That's that Dr. Hasselfelder meme captured me. Also a nice song. But essentially, yeah, that might be close to what is a liquid. But if you're going to say it's a hot, dense state, and you're going to say we have never found evidence for this in a gas there, I just put it into just chat GPT and took like 2 or 3 minutes and it found an article. So like, that's one of the things, because I can put in different keywords and stuff, and you're going to get back all those things with those keywords, and you're going to hope it's going to be what you want. But if you have what I would say is a quote unquote friend that's read the entire internet, should be able to locate highly relevant things based upon the context of the conversation you're having. So that's one of the superpowers. So you don't need it to help it figure it out. If you have a well-posed question, it can help work you through that. And again, one of the big things is, if you're going to state that this is the thing, the way the universe works, and that's not generally what people think, it's like, okay, all you need to do is say, I claim this. The claim is this. I learned that from Wolfram and Garage streaming and everything, because it's like they would have conversations about like almost like the philosophy of physics or the Wolfram Physics Project. It's like the claim would be this, or if that was the case, I conjecture that this is that. Okay, so a lot of these things you can frame it as that, and even was it Curtis's paper literally straight up says, here's our ansatz for the electron. Okay, an ansatz is an educated guess we are postulating as part of the core framework for our model. And that's what you do. You just do the due diligence. It's just some people seem to get kind of invested in different things, and I've noticed, at least over the past few years, it's you have certain folks, and some folks overtly say, and then some folks I've had literally folks that are like, no, my model doesn't have this, so we can't talk about this. And then it's like, well, your model is, and they'll straight up say, it's like, no, this is my religion. It's like, if you're going to question someone's religion, you're basically questioning their foundations of reality itself. And if it's going to be in the context of frameworks of reality, how do you have a discussion? How can you argue with somebody if it's like, all right, the answer is quote unquote God? Now, that might be the answer. Under God, all things are possible. But if we do not know that, and we're mere mortals, we have to grapple with the question of, okay, deity aside, can we figure out what the heck's going on? And that seems to be a much more difficult question. Because if the answer is simply God, and maybe it is, it might be. We cannot restrict God out of the equation. Why? Because at that point, you're going to claim that actually is what is going on. And by definition, We won't get into that. I'm just going to say I've occasionally followed some folks that had claimed to solve the Collatz conjecture, and then low-key in the last minute or so of a video, it's like, oh, and by the way, I am the reincarnation of Jesus Christ. It's like, that's fantastic, Jesus. Welcome back. I still don't understand how you solve the Collatz conjecture. Please elaborate. People have all different, and you know what? If people just want to talk about things, they can believe whatever they want to believe. It's just as soon as you start getting belligerent for different reasons, and it's like you start getting offended because somebody might just disagree with a take on something, it's like, okay, isn't the onus on us to prove it? Because here's the thing. It's like, you might not like string theory. We'll get back to Ed Witten here. It's like, you might not like or believe in string theory. That's totally fine. But can you say it's not mathematically rigorous? Because I don't know. I'm not smart enough to be a string theorist. I haven't gone through all these different this, that, and the other thing. But the claim is it is very rigorous. I talked to a graduate student at one point because I was at like a party for like PhD candidates and stuff like that at University of Utah, and we were talking there. And one of the guys, he had like finished or was finishing his postdoc and everything, is going on to research. He was a theorist. I'm like, what are you looking at studying? He's like, string theory. I'm like, what made you choose that? He's like, it's fascinating. What am I going to do? Don't do something you're interested in? What type of crazy person would say something like that? Listen, if you have the ability to do something that interests you, that you're passionate about, I'm pretty sure your chance of success, whatever success may or may not be quantified or qualified as, is probably going to go up a good bit. So I'm sorry, I'm ranting there. I'm ranting there. Let's see. Okay. I think I saw something about that. It's like a lot of people. And again, just with an advertise like here, I just put Professor Witten. If I just put maybe just Ed Witten or something like that, it's going to get more traction. Why? Because Professor Witten, it's a famous person. It's like when I put Professor Sean Carroll, Professor Stephen Wolfram, or something like that. If I put that in the title, of course, you're going to get more views. Why? Because people are interested what smart folks that they're aware of think about these things. At least more than some scrub like me on the internet looks like a cartoon character wearing a yellow level up shirt and a bandana. It's like, come on, like who would take this seriously? Apparently, at least Stephen Wolfram did, which is, I'm not sure what telling about him or me, but I'll leave that up to the viewer's discretion there. Because it's, well, yeah, I'll click on those videos, and with Terrence Tao, a lot of times people will just kind of throw that around, and I feel like he's kind of becoming is it? I think Kyle Hill did something on this, where it's like the quote unquote AI and kind of out there things, whatever you want to qualify that as, that seem to just be regurgitating scripts from a lot of other folks. What do? Yes, throw Professor Neil deGrasse Tyson or Professor Michio Kaku on the photo. And it's like, here are these things. He's going through the things. It's like Kaku, NJT, no, NGT, Neil deGrasse Tyson, Tyson, Kaku, Tyson, Kaku, Tyson, Kaku. And it's, you can parameterize it. Why? Because that gets engagement. It's like, that's great. Does this help move humanity forward? Oh, it helps fill the coffers. Of course, it helps personally move people forward, and apparently that's all that matters. Because we all know the only thing that matters is winning. It is not how you play the game, but how you maximize the return on your investment. I mean, I grew up hearing other things. I was told it was like baseball. It's not whether you win or lose, it's how you play the game. And then you just live your life experience. And like, well, that doesn't seem to matter at all. Is that just a whole load of like poppycock to try to get things out there? I realize, I'm sure this has nothing to do with string theory or physics or anything like that, because we all know all these folks, they are scientists. and scientists follow the scientific method. What? Oh, we think scientists are human? Okay, fine. They are human. They are human. But we hold certain folks to a higher standard, because if you're going to follow academic logic and everything, you are going to follow it to its full conclusion. It's not like we're just going to do some calculation and be like, well, there's a negative sign here. That doesn't make sense. So we're just going to ignore it and just take the absolute value. I mean, one might think if that was the case, we might be missing something fundamental. Perhaps there's a missing gorilla nobody has noticed. Or maybe some folks have noticed it. But that can't be the case, because if somebody noticed something fundamental, they would tell us. Why? People can't keep their mouths shut. It's not like a long time ago, a whole bunch of smart folks figured most of this stuff out and they kept their mouths shut. That can't happen. Look at the internet. Look at social media. People share everything. Now, okay, I'm going to get back to the chat just because it's otherwise I'll just continue to rant. Let me see. Okay, it turns to I think you have the ability to leave that there in a message or comment here. I think it lets you swap back and forth, at least on a phone, between posting comments for this when basically this becomes a video and live stream interactions. I think I see it but I think a lot of times I'm hesitant about clicking on too many Terry Tao things because I feel like people might just be using it as clickbait now, and especially if it's things you've seen before. A walking quantum computer. Well, it does seem that way. So we should actually get into a couple of things. Well, that's one of the things. If string theory is going to be vindicated, Edward Witten would be the person to do it. I mean, again, it's literally entire fields, to my knowledge, at least according to other smart folks that I've heard on the internet, have been created based upon a lot of string theory and stuff. And you can say like holography, it's like, well, I mean, that was Professor Maldacena. It's like the most cited paper in physics, I think, like 26,000 citations or something. So his H index may or may not be over 9,000. Hold on. One Maldacena H index. Okay. His H index is 126. It's not quite over 9,000, but he's also put out a bunch of papers. Not all of them get cited 26,000 times. So at least that's probably Google Scholar or whatever was on Google when I typed it in there. Yes. Of course. Oh, if I didn't listen to myself, nobody would, right? I mean, come on. Somebody's got to do it. I know. Oh, and like, oh, it's cute. Oh, where's my little black hat? Let's see. Fix it. What did he do? Hey, what's going on, Jax? How are we doing, my friend? We're just discussing how Professor Ed Witten, he wouldn't lead us astray, at least intentionally or something like that. It's like, okay, you listen to Professor Brian Greene. It's like beginning of the 80s. It's like, all right, we have 5 potential candidates for the Calabi-Yau manifolds for our universe. It's like, oh my God, why wouldn't you go into string theory? Heck, even when I was in college, I remember walking through the science buildings, and it's like, it is theorized that elementary strings are the building blocks of reality. It's like, that's in a guitar. It goes ding. Oh, it makes cool sounds and stuff. I'm like, oh, that makes a lot of sense. And then, of course, you have the experimental limits, and we need to connect this back. And well, do we live in 24 dimensions? Is it like a 26-dimensional like Leech lattice or something like that? And sometimes you find different correlations. Sometimes you find what you could claim is evidence. Now, does that mean that is actually the case? Because again, numerology is just numerology until you can explain more with less. Because you don't always add in an epicycle, be like, oh, look, this fits really well. But then we need to do an epicycle after 3 digits, and then we need to do another epicycle, and then it's like you got 5, 6 epicycles, and it's like, okay, we kind of do that in, again, I'm not a quantum mechanic, but usually, at least to my knowledge, your base tree diagram is usually, for like a Lagrangian or whatnot, is basically your classical setup. And then basically you're going to, what is it? We try to normalize different things. You're looking at the difference between potential and kinetic energy, and then we see the difference. We try to see what is going on. Let's see. This Maximus is commenting. What is very interesting. He walked into Princeton's physics department, was told to read certain physics textbook. Next week he came back saying he read it and got accepted into the physics department. I mean that is kind of like Stephen Wolfram. I mean, Stephen Wolfram was like writing papers when he was like 13 years old because like he just picked up a bunch of physics books and stuff and read them, and it's kind of self-taught and was reading papers and had access to the ARPANET back in the day, so he could, like, I think he said his favorite server was, oh god, what is it, Caltech, or maybe it was the IHS, maybe it was like the Princeton's server and stuff. But I mean, he was basically self-taught and everything. So I mean, he, as far as I know, he didn't officially finish high school or even college in the traditional sense. He was just already doing what professional physicists were doing, and he was just kind of the young Wolfram kiddo hanging out with a bunch of older physicists, and just kind of became part of the community. So is that the hardest thing to believe? If he was so bright, and like if you're studying economics and stuff, because like what was it? Back in college, I took modern physics for all like a week and a half. I wasn't able to do some of the homework. I just didn't realize, wait a second, this is like an elective for senior year physics students that have taken physics 1 through 3, all the labs, electromagnetism and thermodynamics. I'm like, this is also back when you had the older archaic systems that didn't necessarily check for all your prerequisites. I talked with the professor and he was like, I'll help you with this. I remember being able to do like some of the homework, doing calculating like the mass energy of, I want to say it was a neutron, but that doesn't make sense. Basically, a particle is probably a proton going 0.9999999 times the speed of light. A whole bunch of nines there, like you would kind of see in like the Large Hadron Collider. And I was able to do the calculation because I also had done, at least was studying management and stuff, and they put you through like some management calculus, and at least the most intense calculus you get is in like finance and stuff. So like I remember my junior year finance class, it's like, all right, I just gotta sit in the back, just kind of joshing around. All of a sudden I do my first exam. I'm like, oh my god, I got like a C, maybe a C minus. I'm like, oh my god, maybe I should actually take this seriously and read the material, do the homework, go to class, take the lecture, read the material again, and then actually kind of know it to the point where you end up getting an A in the class. And even like you'd have that little note card, I would take a mechanical pencil and just write as small as like every single like example and equation that I needed. And then I spent enough time on, I didn't even really need to check. Like I would double check, but I kind of like had at least enough practice that I kind of intuitively basically knew what to do. As the professor was going around, I may have asked, it's like, well, the question is asking this, he's asking for this and this. And then he just kind of raised his eyebrows a little bit and maybe said half a word. And I feel like he kind of told me the answer. I don't know. Maybe he just liked me or something. That's never happened before. But hey, what's going on, Sebastian? Good to see you, my friend. I met some Jesuses. I haven't always been a good person to Jesuses. So my apologies. All right. Dax is commenting about a sim. Here's the thing. I don't think I ever played The Sims. I think I've watched friends play The Sims, but it seems like a really cool game. Or any of those different builder games and stuff like Roller Coaster Tycoon and stuff I thought was pretty cool. Pardon. Well, that's the thing. Yes, these are all different data structures. Kind of like, John Conway's Game of Life. You have some very basic rules, and all of a sudden, what do you start getting? you start getting stuff moving around. You get gliders. You get little like spaceships. And oh god, they get some high-end things where it's like it's extreme complex, like literally like motherships going by and everything. And it's like it tends to seem to give a little bit of credence to maybe what Stephen Wolfram is saying about the Ruliad. And who knows, maybe we're just in the entangled limit of all potential rule combinations. Now, that sounds kind of like a multiverse to me, but it's if you're going to go through all the potential instantiations of stuff and things that could be the case, maybe it is the case. Maybe it's just easier. It's who knows. Hey, maybe you're the player character. Maybe I'm just an NPC. I mean, come on, I look like the dude you'd randomly find outside a shop that's up to no good in a video game. So of course I don't know. Let's see. Where are we here? Vectors do see. Oh god, I was talking to Dan last night. I know Dan and Sebastian had gotten together yesterday, and they were talking a little bit of shop and stuff. And at least Dan seems to be at least the second person to at least say that, to his knowledge, and again, maybe I'm wrong, we were watching Sebastian factorize large numbers in what looks like, to an observer like me, polynomial time. Now, I'm not Ed Witten, but to my understanding from math-type folks much smarter than me, Casey, P is almost certainly not equal to MP. That's what's generally considered, and to my knowledge of what the generalized viewpoint is. Now, if one can factorize large numbers in quote-unquote polynomial time, that is a very unexpected thing. That would change a lot of things, to my knowledge, within mathematics and probably computer science. And potentially this is why every once in a while you'll see like the headline, quantum computer does calculation that would take longer than universe for classical computer to do. It's like, well, that is fantastic. And I don't know if it's always the case, but it tends to seem the case within about a year or so. You end up having a classical computer doing it like it basically a lot quicker than was initially thought. So, I mean, people talk about a quantum advantage, and hey, maybe that's totally a thing. But then I consider, I'm like, well, I went to a quantum computing workshop, was it University of Utah, and they were going through some of the things, and one of the generalized organizers was actually at one of the parties I was at. Very nice guy. But yeah, we were chatting, and then he had another colleague, I think it was from maybe the computer science department, going through like the different Hadamard gates, and just the sheer fact of we seem to be able to utilize all these additional degrees of freedom because it's a quantum thing to figure out what's happening. Now, and Sebastian, correct me if I'm wrong, I think that, to my knowledge, is you're not doing quantum computing, but you've basically, by extending past the division algebras into the Sidonians in order to keep track of primes in some way, it appears that there's almost quote unquote quantum mimicry. That's the best at least I remember from Dan what was going on. So if that is the case, I think that changes a lot of things. And who knows? I mean, at that point, I'm like, do we even need quantum computing? If we don't need to have all this coherence, do all this and that, and we could just literally just do it on like a MacBook or something. Okay, hold on. I'm conjecturing. So yes, I realize we're almost done the show, but let's play the Wolfram clip so we can cover our butts as we conjecture ahead.
Although this is going to be weird, and it's going to be about a different
title of the conference was something like Ground Truth or Turtles All the Way Down. And so it seems as though there's one Ruliad. I don't think it rules them all. And it might be just hyper-rulial turtles all the way down.
Yes, it's on the back of an infinite number of hyperrulal turtles.
Various people are commenting on the outrage of hacking the universe on a MacBook Air.
Okay, welcome, Dean. Well, Dean is bringing it up as far as Professor Witten and string theory. But how many years have they been working on this? I just assume that's string theory. Witten is not Einstein, who worked in isolation. See, that is an interesting thing. It's there seems to be a lot of collaboration, but Einstein kind of seemed to be doing his own thing. It's, again, if you're Einstein, you can basically generally just do what you want, work on the things that you're interested in. You've kind of already proved yourself. You've gathered the essential clout within the field, so to speak. Yep, string theory, yep. All right. So this is one of the things where I've heard Professor Penrose say this. Dean, again, is commenting, good scientists, I think it means do not chase dead ends, or maybe you chase it to the end there. Einstein's latter career, rejecting quantum theory and chasing a theory of everything. Now, was he actually rejecting quantum theory, or was he looking for an alternative there? Just because quantum theory, it's, or at least you have quantum theory, and this is where words matter. And again, I realize I screw up very often because I'm not a professional. I'm a dude pretending to be a science communicator on YouTube and X or Twitter or Blue, whatever dimension you came to this content from. Quantum theory is basically the attempt to quantize stuff past the limits of our classical notions. Okay. Now, quantum mechanics is a particular method of doing that. So, and again, to my knowledge, this is why string theory was attractive to a lot of folks, because initially I think they were trying to use it to help figure out like the strong force. Didn't seem to do that, but essentially the fun statement is it seemed to figure out everything else. Now, did it actually figure out everything else? Doesn't appear that way, but conceptually within that framework, there does appear to be a spin 2 particle, which is believed to correspond with the graviton. And the graviton is a hypothetical carrier of the gravitational force. Yes, general relativity, or gravity is not a force. It's the curvature of space-time, whatever that means. Maybe it is. And it's... See, history is fascinating. That's why I do like... I like listening to Stephen Wolfram and like folks like Professor Barandas, because they'll go in and like cite like the exact papers, because it's kind of ironic, because somebody like Stephen Wolfram, who his mother happened to be a philosopher, he had told himself as a kid, if there's one thing I'm not going to do when I grow up, it's be a philosopher. Fast forward about 50 years, and he's been doing a lot of philosophy recently, so I find that, so he's like, yes, the older me was totally wrong. So that was kind of a fun thing. People apologize. I mean, Professor Susskind, I mean, you can say that. That's an opinion point. Dexter's the apologist. I think he's probably one of the ones where I just got like the statements where I'm saying it's like, yeah, string theory, holography. It's like, did you need string theory for holography? No. But it did seem to be inspired or quote unquote adjacent within a degree or two. So how many degrees of string theory or Kevin Bacon? Can you get to it within 4? Because we seem to live in a 4-dimensional reality. 3 dimensions of space, 1 dimension at a time. What's going on there? Let's see. The pyramid stuff. Jax, I saw Demystify Side did something on that recently. They had a couple of videos, I think, this week on some gentleman saying that maybe they're using it for chemicals or something. I love to think about things like that, but for me, I'm just like, that just seems like we have a whole bunch of wealth and power and a whole bunch of slaves at our disposal. Let's build the most grand monuments ever. Which is more likely? I don't know. I'm sorry, that probably wasn't the answer you were looking for, but it's just, I don't really pay much attention to it. I mean, if you could show me, okay, we have these chemical stores, or like the quote unquote Baghdad battery, that's an interesting thing. Now, that also raises the question of what happened if, I think it was the Akkadian Empire. What happens if the Akkadian Empire like didn't fall or get conquered or all this jazz? What happens if the Roman soldier never pulled Archimedes away from his circles and then like shanked him? It's like, what happens if a lot of these smart folks in different societies kept on going? Where would things have gone? I don't know. Oh yeah, no. Oh, you and Dan. I enjoyed when you guys came by the monastery. That was fun. VCR's Vortex is pointing out cryptography. So, again, I am not a mathematician or cryptographer. To my general knowledge on the topical things that may or may not be going on, the thought is that basically if you can factorize large numbers in quote-unquote polynomial time, whatever that is, that kind of puts current cryptography as we know it in a very precarious position. Now, that's one of the things you hear about for quantum computers and stuff, because they've been telling us, oh, get ready for this. Now, maybe that's going to be what'll happen. Maybe, who knows? Maybe we'll just need big safes again and stuff. So, let's see. Well, this is the interesting thing too, is tools make a big difference. As somebody that was a maintenance guy, and again, a bad maintenance guy, I'm not going to claim I was good. You can screw a screw with a screwdriver. Using a power drill usually makes it a lot easier. Now, again, it depends on what you're doing. If you're trying to hang some sheetrock around a framed out room, yeah, you're probably going to want a power drill to cinch everything in rather than having to turn it and have enough pressure and not wreck the paper on the sheetrock. You're installing a lock set, you probably don't want to use a power drill. Firstly, you're probably just going to want to torque it till it's tight, because if it gets too tight, then the lock's going to have issues and everything. And again, this is a very macroscopic classical observation just based upon my lived experience. Now, if you extend that into physics, we got tools, we got newer, fancier tools. Now, is there something about these newer, fancier tools that maybe we are missing, or maybe something like those old tracks? I remember young Sheldon had one of the things where they were trying to do the neutrino detectors and everything, and they're just looking for like little traces and things. And what was it? I think his mammy or something's like, oh, I'm going to win like a Nobel Prize with these guys. It's like, yes, when am I going to get my Nobel Prize, Sheldon? It's like, oh, no. These things take like decades and decades to go through the scientific process. And mammy was like, wait a second. I gave up some of my stockings for this. What? It was a fun episode. Okay, so let's see. So Sebastian is commenting that quantum computers use a physical basis. He's using an abstract basis usually. I mean, he gets most of the benefits minus the memory. I get interference, superposition, and tunneling. Oh, that's... Oh my... Wait a second. Did you create Blade? Because just the way you were saying, it's like, well, you have all the strengths and none of the weaknesses. Have you created a quantum daywalker, my friend? Okay, so instead of using a physical basis to perform computation, you use a non-physical one that still requires you to provide the substrate to perform this, yes, but all effects you see in a physical QC are present in a non-physical one. Sebastian is using the primes as the QC basis. We can do this because the spectral distribution of primes looks like the quantum chaos. It's the distribution that matters. I'm still trying to grok that, but then again, I did watch something. Where was it? Like Gauss or something. it did something about the distribution of prime numbers or something, and used that as some form of. I feel like I just saw that on Twitter, but then again, my mind just shoots out random things of, is this related? Is this related? I don't know. Okay, so that's about all I got for right now. I actually have to do a hard stop in an hour now because I got to go over to mom and help her out with the dog and everything. But hey, thank you all for watching. Peace out, everybody. Take care out there. It's a wacky and wild world, but it's open for a better tomorrow. Peace out, everybody.